ionization energy. Today we will learn about the ionization energy. What is the ionization energy? Let us now look at the definition of ionization energy. What is ionization energy? The energy required to remove an electron from the outermost orbit or shell of a neutral gaseous atom is called ionization energy. If we think of it as a neutral gaseous atom, if we think of it as a neutral gaseous atom, we can remove an electron from it. We can remove electron from it. Here monopositive ion form. We think of it as a neutral gaseous atom and we can remove an electron from this neutral gaseous atom. Here form a unipositive ion. This is called ionization energy. This is called ionization energy. What is the first ionization energy? What is the first ionization energy? The energy required to remove the first electron from the outermost orbit or shell of a neutral gaseous atom of the element is called first ionization energy. What is first ionization energy? The energy required to remove the first electron from the outermost orbit or shell of a neutral gaseous atom is called first ionization energy. IE1 means first ionization energy. And next one, second ionization energy. What is second ionization energy? The energy required to IE2, second ionization energy. The energy required to remove an electron from the unipositive ion. Remove an electron from the unipositive ion of the element is called second ionization energy. Second ionization energy. This is the dipositive ion. Ionization energy depends on what factors? 5 types of factors influence the ionization energy as seen here. First one, nuclear charge. And second one, screening effect or shielding effect. And third one, penetration power of the orbitals. And fourth one, stable configuration. And fifth one, atomic radiation. Okay, all these factors influence the ionization energy. And now we are going to about the first one, nuclear charge. First one, nuclear charge. More nuclear charge, more is the ionization energy. More nuclear charge, more is the ionization energy. More nuclear charge, more is the ionization energy. Between sodium 11 and chlorine 17. Sodium atomic number how much? 11. And chlorine atomic number how much? 17. Between sodium 11 and chlorine 17, this chlorine atom has more ionization energy. The ionization power of chlorine is high compared to sodium. Chlorine ionization high is compared to sodium. This is because the ionization energy values increase from left to right in the periods. And similarly, the ionization energy values decrease from Similarly, the ionization energy values decrease from top to bottom in the grooves. Top to bottom in the grooves. Okay. Here the more nuclear charge, more is the ionization energy. Between sodium 11 and chlorine 17, chlorine atom has more ionization energy. The ionization energy of chlorine is high compared to sodium 11, and this is because the ionization energy values increase from left to right in the periods, and similarly the ionization energy values decrease from top to bottom in the grooves. This is a nuclear charge. And second one, screening effect or shielding effect. Second one, screening effect or shielding effect. More the shells with electrons between the nucleus and the valency shell. More the shells with electrons between the nucleus and the valency shell, and they act as screens. These all are the screens. Okay. More the shells with electrons. Next one, electrons between the nucleus and the valency shells, and these shells act as screens and decrease the nuclear attraction over the valency electrons. This is called screening effect. What is screening effect? More the shells with electrons between the nucleus and the valency shells, and they act as the screens. They decrease the nuclear attraction over the electron. This is called the screening effect. And more the screening effect, and less is the ionization energy. More the screening effect, less is the ionization energy. If the first group of elements is taken, what are the first group of elements? Hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. If the first group of elements is taken, all of these are also first group elements. Between lithium 3, atomic number how much? Lithium 3, and cesium atomic number how much? 55. Between lithium and cesium, the element cesium 55, this element cesium 55 with more inner shells. Okay, this cesium 55 has more inner shells. So the ionization energy of less than that of lithium. Okay, cesium ionization energy is more than that of lithium 3. Why? Because this cesium 55 has more inner shells. That's why the ionization energy of cesium 55 is less than that of lithium. And third one, penetration power of the orbitals. Penetration power of the orbitals. Orbitals belonging to the same shell have different penetrating power towards the nucleus. For example, in the fourth orbit, that is how this nature is. Okay, here we have to take fourth orbit. 4s is greater than, 4p is greater than, 4d is greater than, and 4f. Okay, here we have to take the 4 orbit. That is how this nature is. 4s is greater than, 4p is greater than, 4d is greater than 4f. This is the 4f orbit nature. Therefore, electrons can be easily removed from 4s than 4f. Okay, here example, beryllium electron configuration. Atomic number how much? 4. Electron configuration 1s2, 2s2. And boron electron configuration, boron atomic number how much? Electron configuration, boron electronic configuration 1s2, 2s2 and 2p1. The element boron has, less ionization energy due to less penetration power of the 2p. Less penetration power of the 2p compared to the 2s. 2p is less than 2s. And fourth one, stable configuration. Fourth one, what? Stable configuration. What is stable configuration? If the orbital in any atom is fully or half filled, then their electron configuration is called stable electron configuration. This require more energy to remove the electron from the atoms in the fully or half filled orbital. For example, here nitrogen electron configuration. For example, here nitrogen electron configuration. Nitrogen atomic number how much? 7. Electron configuration 1s2, 2s2 and 2p3. 1s2, 2s2, 2p3. And oxygen atomic number how much? 8. And oxygen electron configuration 1s2, 2s2 and 2p4. This is the oxygen electron configuration. And this electron configuration can also be written as outer shell electron configuration, nitrogen outer shell electron configuration. Two s orbital and 2p3. This is the nitrogen outer shell electron configuration. And next, oxygen outer shell electron configuration. Two s2 and 2p4. 2s2 and 2p4. It is the easier to remove. This is the nitrogen outer shell electron configuration and this is the oxygen outer shell electron configuration. It is easier to remove electron from oxygen than nitrogen. But why? Because this is because nitrogen has stable half-filled electron configuration. Okay, this is the stable configuration. And last one, fifth one, atomic radius. Atomic radius. Fifth one, atomic radius. More the atomic radius, less is the ionization energy. Therefore, ionization energy of fluorine is greater than that of iodine. Ionization energy of fluorine is greater than that of iodine. What are the elements of seventh group elements? Seventh group elements what are? Fluorine, chlorine, bromine, iodine. All of these are seventh group elements because ionization energy values decrease from top to bottom in the groups. Ionization energy values decrease from top to bottom in the groups. And the ionization energy of sodium more than that of cesium. Next one, ionization energy is expressed in kilojoule mole. Ionization energy expressed in kilojoule mole. It is ionization energy. Thank you.